Okay, Assalamualaikum warahmatullahi wabarakatuh. So this is group 2E from Mechanical Engineering Lab 5, EMM 384114. And this is lab 11, which is measure displacement, velocity and acceleration. So my name is Shamim, and followed by my colleagues Azri and Ikwan, Aina and Juliana. So next. So the objective of this experiment is to determine the effect of force vibration to a simply supported beam in terms of its displacement, velocity, and acceleration. Next. So as the introduction, when the external energy is supplied to a mechanical or structural structure during a vibration, it is claimed that it's to be subjected to a force vibration. So an applied force or an imposed displacement excitation will also have an external energy. So the harmonic and no harmonic yet intermittent, non-periodic or spontaneous force or displacement excitation may be used as the applied force. The harmonic response describes a system response to a harmonic excitation. And therefore the natural frequency of the device as well as the driving frequency of the applied excitation influence the behavior of the system response, which can be also known as the disparity between the driving and normal force frequencies present in the device influence the characteristic of the system reaction. Next. So basically this is the theoretical diagram of the experimental setup, and the equation of motion is used in this experiment as well as the stiffness of the system. So next.
So we proceed for the apparatus. First, we have the computer for the record the data, and then we have National Instrument NICDAQ 9174 for record the data from the apparatus to the computer. And then the figure below show the experimental setup for this experiment, which consists of LVDT sensor, beam, speed control, and vibrator motor. And then you can see on the slide. So we proceed to the procedure. And then the block diagram was set up in the software as shown in the figure below. This is the block diagram for the experiment that we set up on the software. And then we proceed for the, okay. After we set up with the apparatus, now we proceed with the experiment. Okay, we have three speed, which is 280, 380, and 480. So we start with 280, and then we turn on the speed control. So okay, until we achieve 280 rotation per minute or RPM. So this thing will vibrate, and then we collect the data on the software. So the data will be collect for the 10 second. Each second will have 1,000 data, and for the 10-second data we have 10,000 data. So next for the procedure, I will pass to the next presenter. The result.
Okay, thank you, Azri. So I will continue for the result and analysis. So this is the block diagram and front panel in the software that we use in the lab. So this one is for 280 RPM, and as you can see, the right side of the windows shows that the acceleration and displacement graph. So next slide. Okay, this one is for the 380 RPM. So you can see that the acceleration and displacement graph are a little bit different. So the next one is 480 RPM. So this is the graph that that show for the 480 RPM. So next slide, please. Okay, so this is the I combine the three graph that we get from the software that we use in the lab. So this is the blue color is for 280, the green color is 380, the purple color is for 480 RPM. So we can see that the graph for this displacement in the time domain is quite different. So the next slide is okay. So this is the maximum amplitude that we get from the graph from the previous slide. So the first one is 280, we get 1.3916. The next one is 1.3813, and the last one for 480 RPM, we get that 1.6229, which is the highest amplitude compared to the other two. So next slide. Okay, so this is the displacement in the frequency domain. So the color for the graph same as before. So this is the graph. So the next slide. Okay, this is the excitation frequency that we get from the graph before. So as you can see that the frequency excitation frequency for all the speed is 108.9404. So next slide. So this is the acceleration in the time domain. So the color same as the previous slide. So this is the graph that we get from the experiment. So next slide. Okay, this is the maximum amplitude for the acceleration in the time domain. So as you can see, 280, we get 0.3317, and then 2.4480, and the last one is 4.1727, which is the highest amplitude compared to other. So next, okay, this is acceleration in the acceleration in the frequency domain. So next slide. So this is the excitation frequency that we get from the graph from the previous slide. 280, we get 0.9756, and 1.3008, and last one for 480, 1.6260 hertz, which is the highest from that. So that's all for result analysis. I will pass to the next presenter.
So thank you, Juliana. So for the discussion, noted that the harmonic response of the system is affected by the differences of the motor speed. But the result reading for the acceleration and displacement shows the difference in waveform for both time domain as well as frequency domain as well. So the higher the motor speed that has been set up at the first place, the higher the amplitude of the harmonic response that can be observed. By that, the highest amplitude that can be observed at the time domain sinusoidal graph of acceleration against time is 4.1727, and the highest displacement is 1.6229 meter, in which the motor speed was set up to 480 RPM. So that's it for discussion.
So to conclude, the experiment was conducted successfully at determining the effects of the force vibration to a simply spotted wave in terms of its displacement, velocity, and acceleration. And the result shows that the harmonic responses of the vibrating system depends on the speed of the forcing vibration. And as the speed of the vibration force increases, the displacement and acceleration of the simply spotted wave will increases as well. And as you can see from the analysis, the maximum amplitude of the displacement and acceleration of the vibrating system at 480 RPM obtained with 1.6229 meter and 4.1727 meter per second. And while for the smallest, the smallest amplitude of 1.396 meter and 0.3317 meter per second observed upon testing at 280 RPM. I think that it's all from us. Thank you for your attention.